Hi, it's Katie Harris with Philly Wellness Center, and we're talking about high triglycerides. So, when you see high triglycerides on a lab report, and by high, I mean greater than 90, your first thought might be, well, I need to eat less fat. Well, here's this shocking truth about this. High triglycerides are not caused by fat. They're caused by sugar, and more specifically by mitochondria that have stopped burning fuel efficiently. This is the one most misunderstood lab markers in medicine. And today I'm going to show you how high triglycerides actually tell the story of metabolic congestion, citrate overflow, and mitochondrial dysfunction. And more importantly, how you can reverse it. All right, so let's talk about how the system should work. When you eat, whether it's carbs, fats, or proteins, your body breaks that food down into small molecules that end up as acetyl-CoA. This is the entry point into your energy cycle. Inside your mitochondria, acetyl-CoA combines with oxalo acetate to form citrate, which is the first step of the Krebs cycle, the TCA cycle. This is the process that turns food into ATP, which is your body's universal energy currency. Under healthy conditions, the cycle spins continuously, efficiently, and silently like a turbine engine, and it's all great. Citrate flows through the system, it generates NADH, it generates FADH, it fuels the electron transport chain, makes ATP, energy in, energy out, simple, efficient, balanced, everybody's happy. All right, so what happens when modern life breaks this balance? You have too much food, too much insulin, too little movement, too much stress, and they're all sending the same biochemical message. We're full. Please stop burning stuff. Please start storing stuff. We're closed. Your ATP levels rise, and then your NADH-NAD ratio climbs, and the mitochondria become reduced, right? So meaning there's too much energy inside and nowhere to send it. So citrate begins to build up, and this prevents the system from stalling completely. So mitochondria has like this open relief valve, and it's like, let's get rid of all this extra stuff. So citrate is exported out into the cell, which is called a citrate export. And there's a special transporter for that. It's called SLC25A1. Now, here's the important part, because that's not really important. But that exported citrate doesn't just sit there. It's the spark that ignites fat synthesis. So once it's in the cytoplasm, in the cell, so like the hallway of the cell, once it's in that cytoplasm, citrate is converted into an enzyme called ATP citrate lyase, or ACLY, into acetyl-CoA and oxaloacetate. The cytoplasmic acetyl-CoA is the raw material for making fatty acids and cholesterol. So through another enzyme, acetyl-CoA carboxylase, it becomes malonyl-CoA, which is stitched together into fatty acids like palmitate by fatty acid synthase. So those fatty acids are then repackaged into a glycerol backbone to form triglycerides, and the liver sends them into the bloodstream as VLDL particles. So when you get your lipid panel, you see total cholesterol, LDL, HDL, VLDL. So now you know where the VLDL, you know what that means. So when you see high triglycerides on your labs, you're seeing a downstream effect of this entire metabolic rerouting. So your cells are exporting citrate and converting it into fat instead of burning it for energy. So that's why you're tired, you're fat and tired, right? But it's not a fat problem. It's a mitochondrial signaling problem. And so that's what that whole big, if you want to learn about the biochemistry, great. But ultimately, at the end of the day, what you have is a mitochondrial signaling problem, okay? And high triglycerides are a metabolic message to you. They tell your mitochondria are in export mode, burning less, storing more. This happens in insulin resistant. So if you have constant insulin that keeps your acetyl carboxylase and ACLY turned on, they're pushing fat synthesis. And this is a problem, especially if you do have the prodrome or the opportunity for cancer to be there, because guess what? it's using fat synthesis to create cell membranes, and it's using lactate to hide in there, and then it starts pulling cholesterol into those cells, right, which are the building blocks. So your cholesterol levels are going down and you think you're healthy, but it's actually because cancer cells are pulling it in. And it's using all of this fat synthesis to create, to start creating that membrane that cholesterol becomes a part of. Then you have mitochondrial dysfunction, which is oxidative phosphorylation slows, forcing carbon out as citrate. Overfeeding or high fructose diets, such as excess glucose, floods into acetyl-CoA, overwhelming the system, or low AMPK activity, that's the energy brake that would normally shut off lipid synthesis, is missing. So the result, you have high triglycerides, low HDL, elevated ferritin, and HSCRP, fatty liver, which results in brain fog, fatigue, and metabolic syndrome. All because citrate stopped being burned and started being stored. And the end result is you don't have to know any of this. All you have to know that is high triglycerides is evidence of all of this happening. So we have to get your high triglycerides down so that you start burning fat and moving this stuff along. So what's the fix here? Pulling citrate back into the mitochondria. Well, you can't detox triglycerides. You have to restore flow, meaning you have to get citrate moving back into the mitochondria for oxidation. So how do we do that? Well, you can lower insulin and your nutrient load. So intermittent fasting, time-restricted eating, low-carb diets reduce glycolytic pressure and insulin, slowing citrate export. Activate AMPK. Well, how do I do that? Exercise, fasting, berberine, metformin is great for activating AMPK. Cold exposure, they all activate AMPK, which then blocks fat synthesis and promotes fatty oxidation. Support mitochondrial function. So therapies like EBU, methylene blue, NAD, red light, CoQ10, they help restore electron flow and reoxidize NADH to NAD, pulling citrate back into the cycle where it belongs. Strength training and movement. Muscle is like a sink for glucose and fat. So the more muscle you have, the less citrate overflow you'll experience. And manage oxidative stress. So glutathione, alpha lipoic acid, phosphatidylcholine, they all support membrane integrity and redox balance, preventing mitochondrial slowdown that triggers export in the first place. So if your triglycerides are high, don't just cut out fat. Understand why your mitochondria are exporting carbon instead of burning it. It should be burning carbon. That's the whole point of your energy cycle. It's not about eating less. It's about teaching your cells to breathe again. So at Philly Wellness, we specialize in restoring that metabolic flow using testing, therapies, and strategies that reactivate your mitochondria, turn your body back into a fat burning machine, and so that you can feel better. So if you're tired, inflamed, or your labs just don't make sense, this is where we start. Because it's not, in the end, it's not that fat causes disease, it's blocked energy flow.